Alright, in this video I'm going to go over the reasoning for the answers to the questions in the test you've just done. So, question 1 says, the variation with time of the acceleration of a of an object is shown. What's the change in velocity of the object? Well, for an acceleration time graph, the change is the area under the graph. So, this stuff here is added together to give delta v. So, what do we got? What do we have? It's going to be 2 times 1 plus well, I'll split this into this, plus 4 times 1 plus the triangle, which is 1/2 times 4 times 2. So that gives 2 plus 4 plus 4. Okay, so that gives us 10, so the answer is 10. Question 2, we have two blocks of mass m and 2m traveling directly towards each other. Both are moving at the same constant speed v. The blocks collide and stick together. What is the total momentum of the system before and after the collision? So before, this one has pi, the total is going to be 2mv minus mv. So that's equal to mv. And afterwards, we're also going to have mv as p is conserved. So it should be A. Question 3, the graph shows the variation with time of the resultant net force acting on an object. The object has a mass of 1 kilogram, so that's mass is given, and it's initially at rest. So we can say Pi equals 0 and Vi equals 0. What is the velocity of the object at the time of 200 milliseconds? So here we have delta P in a force time graph is the area under the graph. So Pi equals 0. So Pf is equal to delta V. And that's also equal to mv, because we're trying to find the velocity, right? So the area under the graph here is half base times height. So delta P, sorry, Pf is not delta V, Pf is delta P, which is equal to mv final. Okay, so delta P is going to be the area under the graph, which is 1/2 times 200, and it's milliseconds, which is a bit annoying, times 10 to the negative 3, times height, which is 80. So it's 100 times 10 to the negative 3 times 80, which is 8 kilogram meters per second. And so V is equal to P over m, but the mass was 1 kilogram, so it's 8 over 1, which is 8 meters per second. So in question 4, we're told that a ball is thrown vertically upwards, air resistance is negligible. What is the variation with time t of the kinetic energy Ek of the ball? So we have, we know that Ek is equal to 1/2 mv squared, and we could get an expression for this. There are several ways that we could reason our way to the answer here, but we know that Vf, so the V at some time, is going to be equal to Vi plus At for an accelerating object, and in this case it's Vi minus 9.81 t, and so the kinetic energy at any time is going to be equal to 1/2 times m times this whole thing squared, so Vi minus 9.81 t squared. And so we can see that when we start off, we're going to only have the initial speed here, because time is going to be 0. So it's going to be 1/2 m times some big speed squared. So it's going to start off at some big value. So that rules out this one. It's not going to start off at 0. And we can see also that this is never going to be negative, because we're squaring this thing here. So we're going to rule out this one. And we can see that the kinetic energy is some function of time squared. So it's not going to be linear. So it's not that one. So it definitely is going to be this one. So it's going to, as time progresses here, this bit here is going to become smaller and smaller. It's going to slow down. It's going to reach 0. And then it's going to become bigger and bigger, but negative. But because we're squaring it, it's going to end up being positive. So it's going to go down and have 0 kinetic energy at the top, and then head back up. Okay, so D is the answer. Question 5. An object has a weight of 6.1 times 10 to the 2. What is the change in gravitational potential energy when it moves through 8 meters vertically? Okay, so we know F and we know D, or sorry, we'll call that S, that's the IB. Okay, so then it's being moved vertically, so we have work is equal to force times distance, which is equal to 6.10 times 10 to the 2 times 8, which is equal to 4.88 times 10 to the 3. But this was given to two significant figures, so it should be 4.9 times 10 to the 3 joules. So B is the answer here. This is really a significant figure question because they're all correct. Okay, a boat with an output engine power of, so this is power we're given, moves through water at a speed of 10 meters per second, so we're given V. What is the resistive force acting on the boat? So speed is constant. So instantaneous power is given by P equals F times V. And so if it's moving at a constant speed, the forwards force and the backwards force must be the same. So the resistance force is going to be the same as this force. So we have 15,000 divided by 10 is equal to F, which is 1,500 newtons, which is the same as 1.5 kilonewtons. Okay, so this force, this is the force pushing boat, but boat is in equilibrium because it's moving through the water at a constant speed. So F friction is the same. Okay. Question 7. An astronaut is moving at a constant velocity in the absence of a gravitational field when he throws a tool away from him. What is the effect of throwing the tool on the total kinetic energy of the astronaut and the tool, and the total momentum of the astronaut and the tool? Well, before he threw it, he was moving at a constant velocity, so he had some fixed amount of kinetic energy. After the tool was thrown, he did work on the tool, so he added some energy to the system. The total kinetic energy of the astronaut and tool must have increased, so either C or D is correct. The total momentum of the astronaut and the tool, well, in this case there are no external forces, so there should be no change. So D is the answer. A table tennis ball of mass 3 grams is fired with a speed of 10 meters per second from a stationary toy gun of mass 0.6 grams. The gun and ball are an isolated system. What are the recoil speed of the toy gun and the total momentum of the system immediately after the gun is fired? So they were both stationary to begin with, so the total momentum after the gun is fired must remain 0. So it's one of those two. Now we need to work out what the recoil speed of the gun is. So we work out P total first, is 0, and then P ball is 0.003 times 10, which is 0.03 kilogram meters per second. And so the recoil speed of the gun, P gun, must be equal to negative 0.03, which must be equal to M gun V gun. So V gun is 0.03 over the mass of the gun, which is 0.6, and 0.03 over 0.6 is going to give us 0.05. So this one. Note that we've dropped the negative sign, and that's because it was asking about the speed, not the velocity. Okay, A compressed spring is used to launch an object through a horizontal frictionless surface. When the spring is compressed through a distance x and released, the object leaves with a speed of v. What is the distance through which the spring must be compressed for the object to leave at v/2? Well, this is an energy conservation problem, so delta EP must be equal to delta EK. So in the first case we have a half k x squared must be equal to a half mv squared. We'll call that x1. And so for it to be v half of that, if we launch it at v/2, what are we going to get? So we're trying to find x here. So let's rearrange this for x. X is going to be equal to, we can cancel the halves, cancel that and that, and we get mv squared over k all square root. So that's equal to square root m/k times v. So we can see that x and v are directly proportional. So we're going to need to exactly have the distance that we compress the spring if we want half the speed. And that's because this is just a constant here, m/k, and x and v are directly proportional. A motor of input power 160 watts, okay, so we were given a power, raises a mass of 8 kilograms, so we were given a mass at a constant speed of 0.5, so that's a v. What's the efficiency of the system? Okay, so we want to know how quickly the object is producing power, so we know that P is equal to F times V at a particular time, and the force that it's doing work against is the weight of the object. So we have 8 times 10, and in the multi-choice questions it's safe to use 10 because you're not expected to use a calculator. So that's the force is the weight force, times the speed, which is 0.5, so that's 80 times a half, which is 40. So the power output equals power out. Efficiency is equal to power out over power in. This is the useful power out, which is 40 over 160, which is 0.25, and we're to state that as a percentage, it's B. Okay, so those are the multi-choice questions and the reasoning for how to answer them.